So this video lesson is just one that's going to start you thinking about what we might call an inverse exponent. But before you can get to what that idea would even mean, first I want to go over what an inverse operation is. So I want you to pause the video and write down a few things that you remember about inverse operations. Where have you heard inverse operations? What are some examples of inverse operations? What does it mean for two operations to be inverses? And once you've written down those few thoughts, go ahead and unpause the video and come back and we'll talk a little bit about it. So first, just what does it mean for operations to be inverses? Well, in a not quite exact way, but in a way that makes sense, inverse is almost the same as the word opposite. They mean basically the same thing. So we're talking about operations that do the opposite things. And so where we've heard inverse operations before are things like addition and subtraction. Addition and subtraction are inverse operations. And what that means for us in terms of these operations really goes back to solving equations. When we said x plus 7 is equal to 12. Well, here we wanted to isolate x off by itself. In order to do that, we had to get rid of that 7. So to get rid of the plus 7, we subtracted 7 from both sides. And what that meant for us was that by adding 7 and then subtracting 7, we basically undone each of those operations. And so the result is nothing. Nothing has changed if we add 7 and then subtract 7. So therefore, we're left only with x, and in this case, x being 5. So for addition and subtraction, they operate almost like the reverse of each other. And then when we're solving an equation, we can use them to completely clear the operation. That same thing is true when we talk about multiplication and division. If we were to multiply by 3, take some unknown number, let's say x, and we were going to multiply it by 3, and then divide it by 3, in the end, we'd end up just with x. The result would have been nothing changed by performing the inverse. And so that's an important part. That's what we mean by inverse operations. Things that more or less cancel each other out so that the net result is that nothing changes. And if we can use inverse operations with things like addition and subtraction and multiplication and division, a natural question would be, since multiplication is repeated addition and exponents are repeated multiplication, can we use an inverse operation when it comes to exponents? And so I want to take a quick example to remind you that what exactly an exponent is, particularly the exponent 2 and squared. And remember that when we square something, we just multiply it by itself. So 5 squared is the same as 5 times 5. And we get 25. Negative 5 squared is the same as negative 5 times negative 5, which is also 25. Both of those things multiply together to become 25. And basically we sort of write it in this generic form of like some number squared is something else. And so if we were going to talk about an inverse operation, we would talk about going backwards through this. Instead of starting with 5 squared to get 25, we could start with 25 and try to go back and say, well, what number multiplied by itself is 25? And we could say 5. We could also give the answer as, well, negative 5, because negative 5 multiplied by itself is 25. So instead of formatting it like 4 squared is equal to some unknown number x, we would start with a number, say 9, and want to know what can we multiply by itself to give us 9? And that's really the thought behind what's going on when we have inverse exponents. Here, if we think about, okay, well, what multiplies by itself to get 9? Can't be 2, because 2 times 2 is 4. Can't be 4 times 4 is 16. And it just so happens that 3 does a square to become 9. And so I'm going to leave you, this is a very short video, I'm going to leave you with 3 questions. And in your notebooks, I want you to write down a few sentences about the thoughts that you have for these questions. So the first question is, what would it mean to be the inverse of a power? Squared, cubed, etc. What would that really even mean? We talked a little bit about it before with squares, but let's extend that. What does it mean to be the inverse of a power? The second question that you can ask yourself is, what problems might come up when we talk about inverse exponents. I mean, with multiplication and division, we can multiply 5 and divide by 5. We can multiply by 2.83 and divide by 2.83. Is there anything that might be strange if we try to do that with, say, squares? And then the last one is, how would you think about something like x squared is equal to 20? What might x have to be? What's difficult about it? How could we start to understand what this is? So these are the questions that I want you to answer for homework. And when we come into class, we will talk about what your thoughts are for each of these problems. But make sure you write at least a good few sentences and completely explain your thoughts for these questions as we ask them.